Hello, this is Miss Alexander at Mercer. We are going to be going over the SBAC review for 8th graders. If you have Mr. Dixon, Mr. BR, Miss Agapov, or Miss Allen, this will apply to you. I'm going to do this video page by page. So we're going to start off with page 1. It has 2 standards on it. The first one is comparing functions. Find the slope in each equation, table, and graph. Circle the ones with the greatest rate of change. Notice the instructions say to circle, so we got to really make sure we keep track of that final product here. So we're going to look at the first equation. It's in the form of y equals mx plus b. That is the form of a linear equation, where this m right here is the slope. That's the constant multiplier. So we've got m, in this case, is 3. So our slope is 3. We can also say 3 over 1, change in y over change in x. We're going to compare that to all these other slopes and look at the one with the greatest rate of change. Negative 5 over 3, same form, y equals mx plus b. So negative 5 over 3 is our slope. A little harder to find in a table, but we can do it. Change in y is plus 3. Change in x is plus 1. Again, change in y is plus 3. Again, change in x is plus 1. It would continue with the same slope because it's a linear equation. So our slope is change in y is 3 over change in x is 1. Last one, we have a graph. We're going to find 2 points. I'm going to call these lattice points. They're easier to find because they're on whole numbers. So that means we have to go from this point down 5 over 1. So we can recount that if you need to. 1, 2, 3, 4, 5 over 1. Down 5 over 1. So when it says greatest rate of change, that could be either positive or negative. It means the steepest slope. So it's not going to be 3, and it's not going to be this 3, so it has to be either negative 5 over 3 or negative 5 over 1. Well, negative 5 over 1 is just negative 5. Negative 5 over 3, well, that can be simplified. So negative 5 divided by 3. Negative 5 divided by 3, let's just call that 5 divided by 3. 3 goes into 5 once. 3 goes into 20 6 times. 18. Already I can tell this is about negative 1.6. That is not greater than negative 5. So that would mean that D, I'm going to circle D, has the greatest rate of change. It's the steepest line. All right, we're going to go on to problem number 2. We're going to call this 1C. The table shows the cost of renting a go-kart per hour, X. There is a starting cost plus an hourly cost. I also haven't mentioned that these are all just repeats of your interim you took earlier this year. So you'll hopefully find these very familiar. We're just going over the same questions with a different style to them, or different values. So we're going to find the missing values. We've got missing values here, 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 and here, and also down here. It does say that there is an hourly cost and there's a starting cost. The hourly cost we can find. The cost for every 1 hour. Let's figure out what that is. So from 26 up 4 to get to 30 and up another 7 to get to 37, that's up $11 for 1 hour versus this is for 2 hours. So if it's $11 for 1 hour, if this is linear, it should be $22 for 2 hours. Let's check. 22 plus 37 is 59, so that makes sense. That would be 22. Well, now we're missing a value here. We have to know how many hours this represents. A couple ways we can do that. We can figure out how much cost changed by, and that will be able to work backwards to figure out how many hours must have passed. So to get from 59 to 60, it's $1, plus another $30 to get to 90, plus another $2 to get to 92. That's a total of $33. So $33, well, at this rate, $11 per hour, $22 per 2 hours, those are equivalent. I can show that by dividing by 2 and simplifying my fraction, by going down to my unit rate or multiplying and going up. I can do the same thing to get to $33. 33 for every 3 hours would be equivalent to $11 per hour times 3 times 3. So that would be 3 more hours than 5, which is 8. Do it again here just to make sure we're correct. That is a 5-hour change, so it should be 5 hours for $55. Let's see what happens here. They made a mistake. That should be $147. Now usually if you find a mistake like that, don't assume that you're necessarily wrong. If you're really confident that you're correct, then make sure that you tell your teacher that and say, hey, that doesn't really make sense. We are correct in this case, so we'll just move on from that. So now I need to figure out my starting cost, because it asks me over here. I already know my slope. That's my change in cost for every hour. It's $11 per hour. My y-intercept, that's my starting value. I got to figure that out. So if I go back an hour, 1 hour back would get me to 1 hour. So I'd have to take away $11, which would put me at $15. I go back another hour, and I'm at 0 hours. Go back $11. That's $4. Let's make sure that makes sense. $11 plus 4 is 15, and $11 plus 15 is 26. So my y-intercept or starting cost is $4, or just call that 4. My equation would be y equals $11 times every hour plus my starting cost of $4. Which equation shows a lower hourly cost? Now again, this is misspelled. Hourly cost per hour is incorrect. Hourly cost. So to find my hourly cost, I would look at my $11 here. So in this case, it would be $9, that's lower. $12, that's not lower. $4, that's lower. And then it says X. Well, that's a multiplier of 1. That $1 is lower. So see the little S it has here? When it puts an S like that, it means there's more than one equation. In this case, 3 of the 4 had a lower cost per hour. Standard 2 on this interim is about interpreting an equation in the form y equals mx plus b. So let's work through this. A linear function is what that represents, and it makes a straight line. Which of the following is a graph of 4x plus 1? Remember that this is our multiplier, this is our slope, and this is our y-intercept, or our starting value. So to find my slope, I have to find my rate of change between any 2 points. From $1, let's say this is money, up to $5 per day, that's $4 in 1 day. Find this slope between 2 easy to find points, up $2 over 5 days. That was up $4 in 1 day, and this is up $2 in 5 days. So already it can't be this one. My slope is not 2 over 5. I can actually tell you we could stop on this one because the slope is 4, and if you looked quickly you could see the y-intercept right here was at 1. So we do know this one is the correct one, so we'll circle that one, but we'll talk about the others really quick too, because it's not always going to be the first one you choose. So this is the graph of 4x plus 1. This one has a slope of up 2 over 1. This one has a slope of up 3 over 2. So just by looking at these, this slope is not 4, this slope is not 4 either. You could also just look at the y-intercept. The only one with a y-intercept of 1 was the first one. This has a y-intercept of 3, this is a y-intercept of -1, and this is a y-intercept of -3. So I just know that the slope and y-intercept are the same as the equation. I have my work shown, I know I'm correct. Finally, which of the 2 points below is a possible solution or shows that it's on the line of this equation? I have an equation and I have 2 points. I could graph this. I've seen some students make a little graph here. You could also see if this x value and this y value is a solution, or you could see if this other x value and this y value is a solution, if it makes it true. Let's try that method and see what happens. Y equals, I'm going to put a blank where y is, y equals -2x, we'll put a blank there, minus 5. I'm going to see if this x value of 2 and this y value of -1 is going to make this true. So we've got -4 is -2 times 2, take away 5, doesn't make -1. If it does, then this must be a solution to that linear equation. -4 minus 5 is -9. That is not true. -1 is not equal to -9. So 2 -1 is not a solution. So let's try the other one. Same equation, y equals -2x minus 5, put blanks for both. This x value is -2, And this y value, let's use the same colors here. This x value is -2, and this y value is 1. Does that make the equation true? Let's find out. 1 should equal -2 times -2 is 4, take away 5. 1 equals 4 take away 5 is -1. That's not true. So that means that -2, 1 is not a solution. So when it says which of the 2 points is a possible solution, neither. I think I spelled that wrong. But neither one of those points makes the equation true. So if I were to graph this equation, that point would not be on this line, and this point would not be on this line. There's an infinite number of points that are on this line that would make it true, but these are not 2 of them. So those are not solutions. Go ahead and check out the other videos to get help with the rest of this interim review, and make sure that you are spending time making a sense of this and taking notes rather than just watching. You need to be thinking about the math involved, and not just thinking watching it on its own is going to help you, but really thinking about the mathematics I'm talking about will be the helpful part.